What specific problem does the AI scientist aim to solve in the context of automating the scientific research process, and how does it differ from existing approaches?
The AI scientist aims to solve the problem of fully automating the scientific research process, specifically by integrating all stages from idea generation to manuscript writing and peer review, which existing approaches have not achieved. Traditional automation methods have been limited to specific tasks within the research pipeline, such as hyperparameter tuning or algorithm discovery, often constrained by predefined search spaces that require significant human expertise. In contrast, the AI scientist operates in an open-ended loop, allowing it to autonomously generate novel research ideas, execute experiments, and produce comprehensive papers, thereby accelerating scientific iteration at a low cost, approximately 15 per paper. This end-to-end framework leverages recent advances in foundation models to facilitate a more expansive exploration of research directions, unlike previous systems that focused on narrow domains or lacked the capability to communicate findings effectively. Ultimately, the AI scientist represents a significant advancement towards a fully automated scientific discovery ecosystem, capable of iterating on its own findings and contributing to various scientific disciplines.
Can you provide a detailed breakdown of how the AI scientist works step by step, particularly emphasizing the phases of idea generation, experiment iteration, and paper write-up?
The AI scientist operates through three main phases: idea generation, experiment iteration, and paper write-up. 1. Idea generation. It begins with a starting code template, where the AI scientist brainstorms a diverse set of novel research directions using LLMs as mutation operators. Each idea includes a description, an experiment execution plan, and self-assessed scores for interestingness, novelty, and feasibility. The ideas are filtered against existing literature using the Semantic Scholar API to ensure novelty. 2. Experiment iteration. Once an idea is selected, the AI scientist executes a series of planned experiments using the AIDER coding assistant. It runs experiments iteratively, visualizes results, and takes notes in an experimental journal. If errors occur, AIDER attempts to fix the code and rerun the experiments, repeating this process up to 5 times to refine the results. 3. Paper write-up. After completing the experiments, the AI scientist generates a comprehensive manuscript in LaTeX format. It fills in sections sequentially, using the experimental notes and results, and conducts a web search for relevant citations. Finally, it refines the draft through self-reflection to enhance clarity and coherence before compiling the final document. This structured approach allows for a seamless transition from ideation to publication, mimicking the human scientific process.
Could you illustrate the inner workings of the AI scientist with a simple example, perhaps detailing a specific research idea it generated and how it translated that into an experiment and a paper?
One specific research idea generated by the AI scientist was the adaptive dual-scale denoising approach aimed at improving diffusion models. In this case, the AI scientist first brainstormed the idea, proposing a dual-branch denoiser network that captures both global structure and local details in a 2D dataset. It then created a comprehensive experimental plan, which included code modifications, baseline comparisons, and evaluation metrics. After executing the proposed experiments, the AI scientist utilized the results to draft an 11-page scientific manuscript, detailing the algorithm's mathematical description, experimental setup, and results, including visualizations of the adaptive weights throughout the denoising process. The generated paper was structured in the style of a standard machine learning conference submission, showcasing the entire research process from ideation to publication.
What are the theoretical and practical benefits of employing the AI scientist for machine learning research, particularly in comparison to traditional research methods?
Theoretical benefits of employing the AI scientist for machine learning research include its ability to autonomously generate novel research ideas, implement experiments, and produce comprehensive manuscripts, thereby replicating the human scientific process in an automated manner. This end-to-end framework allows for a broader exploration of research directions without the constraints of human ingenuity and finite time, potentially leading to more innovative discoveries. Practically, the iScientist can generate hundreds of medium-quality papers at a remarkably low cost, approximately 15 per paper, significantly accelerating the pace of scientific iteration compared to traditional methods that require substantial human effort and time. Additionally, the automated reviewer integrated into the AI Scientist achieves near-human-level performance in evaluating generated papers, ensuring quality control and enabling the selection of the best ideas for publication. Overall, this system not only democratizes access to research, but also enhances the efficiency and scalability of the scientific discovery process in machine learning.
How was the effectiveness of the iScientist validated through testing, including the datasets used and metrics applied to measure its success?
The effectiveness of the iScientist was validated through extensive testing on 3 templates across various publicly available large language models, LLMs, specifically Claude Sonnet 3, 5 GPT-4o, DeepSeek Coder, and LLAMA 3.1405b. The evaluation involved generating around 50 ideas per run, which were then subjected to an automated novelty check, successful experiment completion, and the generation of valid compilable manuscripts. The performance of the generated papers was assessed using an automated reviewer based on the ICLR 2022 dataset, which provided numerical scores across multiple metrics, including soundness, presentation, contribution, and overall quality. The results indicated that the LLM-based reviewer achieved near-human-level performance, with a balanced accuracy of 65% compared to 66% for human reviewers, and demonstrated a correlation with the average scores of human reviewers, suggesting that the automated process aligns well with human evaluation standards. Additionally, the cost-effectiveness of the system was highlighted, producing papers at approximately 10 to 15 each, which underscores its potential for democratizing research and accelerating scientific progress.
What notable results and insights were achieved through the use of the iScientist, and how do these results contribute to the broader field of machine learning research?
The AI Scientist generated numerous notable results, particularly in the domains of diffusion modeling, language modeling, and grokking. For instance, it produced a paper titled Adaptive Dual-Scale Denoising, which proposed a novel dual-branch denoiser network that effectively captures both global and local features in 2D datasets, achieving significant improvements in sample quality and KL divergence metrics. Additionally, the automated system demonstrated the ability to generate comprehensive manuscripts, including precise mathematical descriptions and innovative visualizations, which are essential for communicating scientific findings. The framework's cost-effectiveness, producing papers at approximately 15 each, highlights its potential to democratize research and accelerate scientific progress. Overall, these results not only showcase the capabilities of the iScientist in generating valuable insights, but also pave the way for future advancements in machine learning research by automating the ideation and experimentation processes.